All right, welcome, ladies and gentlemen, to the 7th annual CCM Engineering Shark Tank. To first order, hats off to our engineers. Please stand up, guys. All right. Once again, each guest should have picked a role that they will play today, either as an investor, contract manufacturer, tech partner, tech fanatic, and other different roles. As we witness the showcase of these products, feel free to reflect, transform, and ultimately, after 20 minutes of presentation for each company, we have the opportunity to have a 10-minute Q&A. The most important part is really to believe that engineers can be part of this revolution of engineering solutions for humanity. Our theme for this year is engineering solutions that enable the pursuit of Maslow's hierarchy of needs. That's a psychology concept, but it's an important concept. Engineering solutions that enable people to have shelter, security, love, belongingness, and the ultimate of Maslow's hierarchy of needs, purpose, self-actualization. So before much ado, hats off once again, especially to our first company, SKA, and I'm pretty sure you will be impressed by their journey and solution. A round of applause for SKA.
Hello, everyone. Welcome to our Capstone presentation. My name is Andres Brito. I'm the lead design engineer and the manager for SKA LLC. To my right is Seth Mattison. He's in charge of marketing and research. And to my right over here is Kyle McKenna. He's in charge of our programming and also procurement. Our problem, so over here is Maslow's hierarchy of needs. At the very bottom, we have psychological or physiological. Above that is safety, loving and belonging is on top of that, self-esteem is right above that, and then at the very pinnacle is self-actualization. Now, with Maslow's hierarchy of needs, we ended up choosing safety as our focus, and since it is a psychological pyramid, it is needed for every person, and while everyone wants to focus on self-actualization, not everyone can focus on that, because if the other tiers aren't met, you can't focus on that. So part of our presentation also focuses on self-actualization, but the main focus is on safety. All right. The main safety issue our problem focuses on is school shootings. School shootings is a very serious topic for us. It's not something to be taken lightly, and it's really serious. One of the issues with it is that, statistically speaking, that school shootings have doubled from 2017 to 2018. Have doubled. And then any years previous from 2006 and onward have been increased rapidly high. Okay. Explaining our research is Seth Mattison.
SKA, feel free to use the front of the tables also to walk back and forth if you want. Okay. All right.
Mm-hmm. Sorry.
Kai, you want to sit over there? So we can have a span of SKA company.
Right.
Yeah.
Okay. I'm Seth. I was in charge of research and marketing, and this is what our research has found for the issue of school shootings. As Andres said, from 2017 to 2018, the number of school shootings doubled from 44 events to 97 events. And this is the highest since 2006, which was at 59 events for the entire year. Now, the database we used also showed that from January 2019 to March 2019, there have already been 23 shooting events at schools. Now, since we're focusing on safety, we used the database we found to take a look at where these shooting events were taking place. They found since 1970, 693 events occurred outside of the school, but almost just as high were 602 events that occurred inside of the school building. Now, since, again, we're all focusing on safety, we looked at the perpetrators. We found that since 1970, there have been 703 school shooters were students who were currently attending that school, which is the highest percentage of the perpetrators. The next highest was unknown, only at 250. 140 perpetrators of the school shooting had no relation to the school. So the highest number of school shooters were students. And the number one reason for an attack on a school was an escalation of a dispute, either from an argument or from a school bullying that led to a violent attack. Now, since school shootings have been publicized a lot in the media, you may have heard of politicians and congressmen talking about adding armed police guards or arming the teachers to try to protect the students, but actually our research found that this is, the data shows that there's conflicting research on this at best. Armed guards and teachers can actually make students more afraid to go to school, especially those who were previously victims of a school shooting event. Just the presence of a gun in the school can make people too scared to learn anything. Also, police in the schools, armed or not armed, also adversely affect minorities. Because, if an event occurs like a fight or any kind of argument occurs and the police officer steps in, the police has priority over any ruling by the school. So if the school would just have like a suspension or after school detention, if the law says that there's a required minimum of jail time, then the police take precedent. Doesn't matter what the conflict was, once the police are involved, they have the final say. And this all adds to a growing problem of what's called the school to prison pipeline, where students end up with criminal records, can't get jobs after school, after they graduate, and have a harder life that either forces them or ends up with them becoming a career criminal. Also, the research is contradictory. There haven't been a lot of research on the long-term effects of police in schools or armed guards in schools, but in some cases it shows that it lowers the number of violent fights, but in other cases it can actually increase the number of violent fights because students feel mistrusted, and the police, again, can arrest people from anything from violent fights to even minor infractions like violating the school dress code. And so to talk about what our proposed solution to this is, Kyle McKenna.
It's very sobering. It's an issue.
Okay. So I'm Kyle. I was in charge of programming and procurement for the project, and I'll be talking about our solution. So when we were thinking about our problem, our solution, we wanted a device to keep students safe and be able to deter an active shooter in any situation. Our device also needs to be able to alert emergency services in order to get them there as fast as possible. Because if you have like a teacher or like a student call, it might not happen as soon as the first gunshot goes off. So, speed is always the key. Our device needs to have a manual override in case, like let's say the shooter is on one side of the building, but the doors lock, all the doors lock, and then students on the other side of the building, they shouldn't just be locked in their classrooms. The teacher would be able to manually override the door lock to be able to get out to safety. Our device needs to be not intrusive and very discreet. This is in order to for the students, kind of for the students' peace of mind, because if there's this big hunk of metal like strapped to a door with a giant deadbolt, it's like a constant reminder to the students that just in case, like this is there if a shooting is where it is to happen, but we don't want them thinking that at all. All right, and lastly, this device just needs to be really easy to use because we don't want to like infringe on the teachers, and we don't want it to be a burden on them when they have to use it at all. We want it to be really easy, like a push of a button. Their door, if it's locked, can open, or if it's not locking, to lock. Really easy, push of a button. And this picture here is just a block diagram. This also goes over our PIPO or PIPO, which stands for Power Input Process Output. So the top block is a 9-volt battery. That's our power. On the left, these gray squares is our this is all input. So we have our microphone for the input, our manual switch, which should be the override for the teachers, and a Wi-Fi receiver. And that's for all the doors are connected through the network. So if one door locks, in order for the other doors to lock, it needs the Wi-Fi receiver. In the middle, that's our process. That's the circuit itself and the locking mechanism. And then on the right, the blue squares are the outputs. So we have the door lock itself, the Wi-Fi transmitter, the LED light to signal if it's on or off, and computer memory to store data from any situation that happens. And this link here, Seth's brother is a teacher in Virginia, a high school teacher. So he reached out to him asking about our idea and what he thought about it. And so I will read out his letter real quick. So he says, I'm writing in response to your proposal of an automatic locking door mechanism as a defense measure for the school. As a secondary education teacher in Virginia's Prince William County, defense of our school and students is something that teachers are becoming more trained for and aware of each year. I've been teaching at Patriot High School for the past 4 years and have received training in lockdown emergency drills and weather-related instances each year. Our training focuses on the classroom and the methods to secure the room and students therein, or to safely move students to the appropriate location inside or outside the building. We have training, but are always looking for ways to improve our security. Having an assisted locking mechanism on doors would be beneficial to students and teachers in the event of an emergency. It may require additional training, but having a system that prevents human error from putting someone in harm's way would be worth the additional training hours. A door that is always secure is less likely to be targeted or breached in any event and makes students and myself feel more reassured. I am interested to see the practical applications and results from any testing that is conducted of this suggestion and would love to hear about any potential trials that could be conducted. And that's from Seth's brother, Herman Matthijssen. All right.
Engineer Kyle, that's pretty impressive testimonial right there.
All right.
So continue on. Yeah.
Sure. All right, next slide. Oh, wrong button. What is this one? No. This? Either way, let's go into our slide. So this is our developing solution part. So when we were making our device, we had these things in mind. We needed our devices to be able to talk to each other through the Wi-Fi, like I said earlier. That's so if one door locks or all the doors lock, to make sure they're all safe and secure. It needs to be able to transmit data to the emergency services of the cloud, which would be for the school administration, for like 911, or for police, or for EMS if they need to come. We needed our device to have redundancy in the safety mechanism, which is, so like, let's say the microphone, which would detect the gunshot, if that's not working, there needs to be another way for the door to close, and that would be either through the Wi-Fi or through the teacher manually locking the door. It needs to be self-reliant and has to have a low power consumption. because a device like this is always going to be on. So it needs to be able to stay on for a long time and not use a lot of power. We needed our lock to limit human error in an emergency, just because if someone could mess up, you don't want someone not locking a door to be the reason why people get hurt, you know? And lastly and mainly, we want this to prevent intruders from entering the classroom, you know, just in general. If a door is deadbolted locked, an intruder's not going to stand there for like minutes trying to get in. He's going to go on, you know, he's not going to try to get in. All right. All right. And this picture on the right here, this was actually our first schematic of our drawing for our circuit, for our first prototype. I'll give the floor to Andres. He will explain that.
Thank you, Kyle. Okay, so over here is a schematic of what I came up with at the beginning. So originally we needed something to input, so it was a microphone. We needed to filter out the low frequencies and the high frequencies, anything that was in between what the microphone couldn't pick up, just to eliminate any errors at that point. After that, it would go through a couple op amps, more filters, and just to amplify the signals, because the main thing we were focusing on was the sound intensity of the gunshot. Gunshots are really loud. They're around 110 to 140 decibels. So we picked 120 just to be on the safe side in case any of them are suppressed, any of them, you know, are like handheld, so you can't. So it didn't produce less noise than actual like AR-15 or AK-47 at that point. So continuing on with the circuit, it goes all the way down. Once it goes through the amplifiers, it goes through even more to activate a couple of LED diodes. Those LEDs indicate what level of sound intensity was that it was hearing. That was just for indication to see if it was actually working or not. To then at that point go to an analog switch. From that analog switch, because our signal was analog and our input was analog, it would flip it down to a bistable 555 timer. With that meaning that the timer wouldn't output a signal at all up until it received an input. That being said, once it input it would go to an AND gate, which would then go to our other circuitry, being like the Wi-Fi receiver in case for redundancies, and then just output to the locking door mechanism at that point. Okay, so as I said before, this is us prototyping. As you can see, I am holding a decibel reader because we needed to see that, like how loud things were. Ambient noise is around 50 to 60 decibels. So you can see me trying to figure out like if frequency affects that at all. Frequency doesn't so much. It's more so just the peak to peak voltage that we're looking for. All right. We're also trying to detect inputs from obviously manual switch. Making sure our door lock was engaging. As in the bottom corner, you can see that is our circuit that we built and ended up running a couple microphones in the process. Yeah, and it would just send out a signal to emergency services. Next slide. Okay, this is our refined one, the one that we actually came up with. So part of the issue that we had with our previous circuit was that it was power hungry because we were using op amps. The op amps, the ones that we had, were using around 15 or so volts, and that was too high for us. So we ended up going to a lower solution, something that was already more like developed, and we could fine tune even more. So we chose with the Arduino circuit. With that, we included a wireless charger because Arduinos also, they can draw a good amount of power, but with the wireless charger being on the door hinge and the door lock, even if it's closed at night, because schools are required to close doors at the end of every day after janitors leave. So our circuit would be charged at that point from then on. And afterwards, we still had everything else afterwards. And yeah, we had a stepper motor. Originally, we did have a servo motor, but because it wasn't strong enough, it didn't have enough torque, we went with a stepper motor to actually move the deadbolt. Okay, next slide. And then that's us continued to prototyping. As you can see, there are some 3D printed parts that I manufactured myself at my own home. Yeah. Next slide. Okay, and then to explain more of our marketing would be Seth and Tyson.
Hello again. All right, so for our circuit, is this the right one? No. Which pocket did I put it in? There we go. Okay. So as far as marketing this or selling this to schools, overall we found that parts and labor, we estimated the cost per unit to be about $160. Now, traditionally, if you're going to make a profit off of selling each unit, you usually triple that. So that would put us in somewhere in the neighborhood of $475 to $480 per unit. Now, if that sounds expensive, that's because it is. A quick Google search on Amazon shows that even the most expensive door lock, a Bluetooth-enabled door lock that you can switch on and off with your cell phone, only costs $350. So if we were going to sell this, we cut back the price to match the Bluetooth at a $350. So most of our profits, if we were going to, when we're selling this in the market, would have to come from secondary costs, like maintenance and service calls. Now, right now, it's just the three of us. That's not a lot of people, so it makes sense that if we're in schools, there's a lot of schools. Three of us aren't going to be able to cover all that by ourselves. So what we would do is we would sell service contracts to third parties to maintain the door locks for us. We would train them on how the circuit works and how to check the calibration to make sure everything's working. And we would charge people maybe in the neighborhood of $20,000 for a 4-year contract with us. And we would, for installation, we would probably be able to cover the installation ourselves. Once we get some starting capital and we hire some employees of our own. Now, I found online that you can estimate the number of doors in a school building by adding 2 doors per every 25 students that go to that school. And since according to our research, most school shooter events are students, and the most common age is 17, we focused on high schools, which is about 75 classroom doors per school. So that would be our starting flat rate for installation. Anything above that, we would charge per every 5 doors. Now, we would also see some secondary income from annual inspections, because these doors will have rechargeable batteries. As great as rechargeable batteries are, they do wear out. And by no means is any circuit perfect, so the microphones will have to be checked for calibration to make sure that they're still working properly the way they're supposed to, or the way that we expect them to. And since we're also using a Wi-Fi network to connect all the doors and collect data, we also want to make sure that the cybersecurity on these doors is up to date also. So an annual inspection makes the most sense for maintaining these. And yeah, I think that's it. Now we're ready for a demo of our product.
Now,
Feel free to invite the audience in.
Yeah.
Now, just a little disclaimer with our demo. We ended up going through a lot of microphones. We ended up putting too much power through them on a voltage, so they ended up frying. So last minute, I had to run all the way to Micro Center in Westbury to find a microphone for us. Now, that one is really sensitive, and it can only pick up an acoustic of 60 decibels, which is ambient noise. But once it hears it, it'll activate. Yeah.
So you guys want to come up?
Come on up, guys. Yep.
Also, with this, we made the door ourselves, and we're not carpenters, so
And just make sure the video camera has a wide view. That's a school door, right? That's one of the 75.
that's just because we're holding it offset. So So just to give you a quick demo, this is the power supply. We didn't get our battery in time because it would have taken 6 weeks at that point for it to come in. This was the battery that we did want, which is one of the issues we had built into. So in supply, we have a 9-volt battery pack onto it, just for now. But the Arduino can output 5 volts from that with the battery, which is supplied to the connected. We have our servo motor over here, and then our inputs in LED. Right? And then when I plug it in, then if I press the button here, which is the override, hold it, it pulls it over. Now, one of the issues that we did have, once it relaunches itself, is it just to make sure if any teacher wants to let any students in that they feel,
So it pushes back in, that's great.
needs to come into the classroom. Let's say they couldn't find the classroom and they hear, hey, let me in, I need to get in. At that point, it would be up to the discretion of the teacher, but we build an override. So on top of that, this right here, this wire signifies a latch. Original latch that I created ended up breaking and was bad during manufacturing. In that box right there, I have all the scraps that I 3D printed, a lot of brackets. I took hours. The enclosure itself took around 16 hours to print. And everything else. Over here, we have a little deadbolt that I also printed brackets. I couldn't get the real ones to work, so we just settled with this. The latch here is in case someone needs to get in. You just break the latch open, and then you can unlock it manually.
Pretty impressive, right? So the inputs could either be the metal override, Wi-Fi, or the microphone with the intensity of the bullet.
We're not shooting any bullets.
Circuit.
No, we're not doing that.
No bullets. Yeah. I would like to see that.
That's next year.
They're pretty impressive. All right.
Thank you.
We're going to do Q&A.
Okay. So we want to give special thanks to Professor Carcano just for hosting us and letting us go through his experience. This was honestly one of the most humbling experiences I've had as a student here. I've been a student here for a good amount of time, longer than I care to say. But all in all, it was a great experience that we had, and it was an honor to be your student, Professor.
You're welcome.
On top of that, we want to thank CCM's Speech Tutoring Center for helping us out, giving us insight into what the product is and just essentially just helping us prepare for that. Arduino form for giving us code and helping us out with the design for that, because we obviously weren't that well versed in that. It's been several years since I've coded, but overall it helped us out in just giving us an idea for a code. After that, we want to thank Seth's older brother for helping us out with the letter at that point. Professor Balaki, who that is misspelled, for letting us use all the op amps
Balaki with B. Yeah, sorry.
that we ended up using for our first experiment, and and also Micro Center for the amount of trips that I went there, because the amount of trips I went there was, I think, around 8 or 9, including the one to New York.
All right, SK, thank you so much. Have a seat in the special Q&A table. Round of applause for SKA Company. All right, we'll have a 5-minute Q&A. Once again, to those folks who just came in, welcome to CCM's Engineering Shark Tank. Feel free to get food. Make sure you get a judge's sheet so that you can judge based on the rubric. All right, so once again, each and every company here will proclaim their experience here as a Capstone project, which includes engineering a solution for humanity. And I think this very first company is pretty impressive. At the end of the day, just imagine what role you play as educators here. We want to always be inspired. We want to always be positive. But sometimes the elephant in the room is safety. And they are willing to address that. And hopefully with the role that you're playing right now, you're willing to give us feedback and provide funding. Any questions for SKA? Commercial questions, operator questions, technical questions?
I walked through a mic, but I've got a question. If the battery dies, what state is it? Normally closed, normally open?
So for the battery at that point, we have it set to where it's detecting, like the circuit's always going to be on, it's always listening at that point. The battery will be charged through wireless charging through the door latches. So, and since wireless charging, you don't need a physical connection, the door can always be open, it can be closed at that point. So the battery that we use is a 4.6 milliamp hours. Our circuit, if it were to be running, including the motor just constantly on, draws around 200 milliamps. Doing the calculations, that's around 4.4. So even if it runs for the entire day, the battery, it'll still have enough juice for the battery. And since what is it? since schools have to close their doors at the end of every single day, the system will get charged throughout the night.
Okay. But from a safety point of view, from an egress point of view, if there was a fire or some reason people had to get up, you should demonstrate that they can manually override it.
Mhm.
And if there was a battery problem, you could still manually override it, correct?
Mm-hmm.
Okay.
And also on top of that, one of the issues I also wanted to address as well is that with sound intensity and like decibels, all that type of stuff, one of the issues that we faced was just discerning whether with the gunshot, if like what it would pick up, because with decibels, it's all relative to like distance at that point. So as Professor Balaki once like told me yesterday, like he asked me a question whether or not if it could discern between lightning or gunshot. Ours would be able to, just because since lightning is further away, or even if it strikes close, other systems at that point will have the redundancy to where if it doesn't pick up at that point, it won't lock it won't lock. Also, it can also be overridden via like principal or someone else to turn them off in case of an event. Let's say schools have like a spirit a day where all like the band is playing really loud throughout the hallways. Like it can be disabled during that point.
Good response, Engineer Andres. That's part of our total solution here is holistic, the user experience itself and durability. So fantastic job, SK. Great question about battery life. Normally on, normally off as well. Any other questions? Professor Aska, Engineer Aska, Investor Aska?
All right, I just want to know, how do you test the system to know that it will respond to a certain decibel?
Know that it will respond?
Yeah.
Well, we use an oscilloscope at that point just to see whether or not our microphone was working. The Arduino itself has an ADC converter, meaning that it'll convert analog into a digital signal, and with using the IDE, which is like where we could program, we could see whether or not it was picking up the signal and to what value at that point. So based on that, the max input voltage peak to peak is 5 volts for the Arduino for the ADC. That being said, we can characterize that to 140 decibels to be 5 dB, or to be 5 volts.
So what do you use to create this sound?
Well, we basically at that point, since for ours, the max it could go up to was 60 decibels because of the microphone. The one we used originally could go up to 120. It was just the ambient noise at that point, because ambient noise is 50 to 60, which is already the max threshold it can pick up. So just by for us turning on the circuit it would already activate just from hearing everything else.
Yeah, if we were going to go into production with this, obviously we'd have much better microphones than something that maxed out at 160 decibels, but hopefully we'd be able to put together a database of known sounds. Like we would test the microphones for thunder, test it for different types of firearms, and all of that would be part of the door's system. And then if the door would pick up anything from the microphone, we could hopefully be able to compare it to a database of known sounds to know if it's thunder, if it's a gunshot, and compare it that way.
Also, another thing to add in addition to that is that right now this is a basic prototype. With the amount of resources that we had and limited funding that we had, we can only do so much with it. Another plan with it is to be able to track where the gunshot was set off, because the thing with gunshots is it's followed by two things. You have the initial shot, and then after that, another second wave, which is the echo, or when the bullet breaks the sound barrier. So our bullet would be able to detect, or microphone would be able to detect that with our coding, and then at that point, since the shock wave is directional and can only be heard like mostly forward, at that point we would have it so it would activate.
Yeah, 2 more questions. The engineer asked, the investor asked, and thank you again for your question, particularly in characterizing the sound of gunshots. As an educator myself, I was very moved by the project, especially the product presentation. Any educators in the house here that were moved, and any comments about their approach? From a user factors, is there another input that they should have considered? Educators in the house, safety perspective. Principal Balki? Yep.
There has been a discussion at the adjunct faculty meetings a few years ago, locking the doors as soon as you start the class. I don't do it. Some of my students here, I think, appreciate that when they come late.
That's right. So ultimately, SKA's solution will ultimately start that discussion. Should there be a universal lock? Should there be an override by certain trained folks in the education community? But it's really a thought-provoking project, and hopefully you will fund their project. Once again, a round of applause to SKA Company, especially for being the first company to present. Thank you so much. All right. Our next group is Circuiteers. Please do come up. A round of applause for Circuiteers. All right, to the audience, once again, you will see a certain pattern with the presentations. They will go through the entire engineering design cycle from problem identification, developing a solution, prototyping and testing, to soliciting your feedback for the future redesign and funding. Circuiteers, take it away.
Good evening, ladies and gentlemen. I would like to introduce you to our new product, the computer, your own food computer. We are the Circuiteer Design Manufacturing Corporation. I would like to introduce to my team that make this product possible. Meet our technician, Joey Doherty. Meet our system engineer, Edwin Flores, and myself, the project manager, Cindy Ramsey. Why food waste is such a big problem? We developed a device using the Maslow hierarchy. I'm from Trinidad and I'm from the rural village. Residents earn their living by fishing and farming. My town has been affected by the rising sea level. Here is a map showing Icacos Point not far from my home, where the Constance Building and Icacos Lighthouse is shown. This is the aerial photo from the, next to it is the aerial photo from the go back up. This is the aerial photograph from the 1994. Much of the Coral Point and the Constance Building have disappeared into the sea, including the Icacos Lighthouse. Climate change is worse in coastal area in my area. Trinidad is under threat as the sea rises. The sea region has risen by more than 2 millimeters a year. Here you can see homes, roads affected by the coastal erosion not far from my home. Large portions are being lost to the Gulf of Paria. This is a prediction of the street map of New York City showing maximum projection future storm surge. The projection is a 500-year-old flood, 1 in 500 chances of occurring in any given year. If sea level rises, the lower Manhattan would be submerged in water. Battery Park, you can see it, and you can see water in Battery Park, and the 9/11 Tribute Museum, and most of the South Street Port would be in bad shape. Here, the data showing the effects of sea level rises in New Jersey. The sea level around Atlantic City, New Jersey, has risen by 12 inches since 1950. It's a speed rate of acceleration over the last 10 years. It is now rising by 1 inch in every 5 years. Scientists know this. It has been measured every 6 minutes using equipment like satellites, floating baryons, and tidal gauge. Imagine if for every 5 bags of grocery you buy, you just threw 1 away. That's exactly what we're doing. When food is thrown out, it goes to the landfill. When organic matter breaks down into anaerobic condition, it produces methane. Methane is a powerful greenhouse gas. The breakdown of organic matter in landfill also produces potent liquid called leachate. Leachate can be toxic to the environment. It can contaminate groundwaters and waterways. Here's a chart showing the largest emitter of greenhouse gases. China is on top, US is second, India is third, and Russia is last. Just how big food waste is, roughly 5.4 million square miles, which would make it second largest country in the world behind Russia. Overall, grain and meat are producing most greenhouse gas emission. Switch. Here is a typical farm from back home in Trinidad. The shed are for drying coffee and cocoa. At my house, we had chicken, ducks, goats, cow, and house pet. For us, food was never wasted. Whatever food was left over after meal, we collected and put into recycling machine. Switch. All right. These are our recycling machines. We fed animals with leftovers. We never threw food away. We constantly recycle it by feeding it to the animals. When I first moved to the US, I was surprised that the food was being thrown into trash. I was astounded by so much food waste. I realized because of the city area are crowded. So it's impossible to recycle food. The UN Food and Agriculture Organization has said that a third of all food produced worldwide, worth $750 billion, is thrown out each year. Food waste, which often end up in landfill, this releases 3.3 billion tons of greenhouses each year. If food waste were a country, its carbon footprint would be a third only to China and the United States. This is a pie chart showing the biggest source of food waste. Restaurant is the second biggest. Well, the resident is the biggest source of food waste. Restaurant, the second biggest. The grocery stores are third. Here you see the food waste goes by category, each section, where the dairy, nuts, and grains. The average American family throw away almost $1,500 per year in food. One of the biggest area of waste is cold chain. Almost 20% of the global food loss is caused by incomplete cold chain. This means that all players in food supply, includes shippers, warehouses, have a role to fill when it comes to tackling challenges of food waste. The refrigerated food industry is seeing staggering amount of waste at every step of the cold chain supply. The retail stage is especially waste prone. 80% of the food loss take place after the retail level is the United States. In the United States, most of this trash food is comprised of refrigerated items such as produced meat, seafood, beverages, and ready-made food. What can we do to solve this ongoing problem? Can we fix this problem? My team and I came up with an idea that would help each consumer to reduce food waste and save money. We wanted to engineer a solution to prevent this. What if we build a device that prevents food from being waste? Joey, can you tell us more about our solution to this problem?
Thank you, Cindy. Hello, I'm Joey Doherty, the system technicians for this project, a systems technician. So obviously food waste is a big issue nationally and internationally. It is harmful to productivity for businesses, and frankly, it's also immoral. So what we wanted to do is look at some solutions that people have tried to figure out. So we looked at some technical solutions, and we'll also look at some legislative solutions from the government. So since our device is in the kitchen and it'll go right on your refrigerator, that was our ultimate solution. But here's an example of what people have already come up with. This is the Samsung refrigerator. So it has a computerized system to already keep track of food and to help prevent food waste. But the problem here is this device will cost you almost $4,500, and not to mention revamping your entire kitchen. So our device prevents you from having to do all that. So what is Congress doing about it? We'll talk about, so in December of 2015, Congress added to the omnibus budget bill 15% tax deduction for all businesses donating food. It had previously been 10%, but they decided to up the ante on that and give people more of an incentive to donate and help with this problem. Also, in 2016, they passed the Food Date Labeling Act. Now, the reason they did this is because people were throwing away food that they thought was bad because of the expiration date. But what they didn't realize was that's just a quality date. So the food is still edible. It's not in the best condition, but it's still safe to eat. So what Congress did was they made a law that said you have to have a safety date, which would make sure that's when the food is bad. That's when you can't eat it. And they would also have a date called a quality date. Now, this would be optional. And they also require businesses, you have to explain what these two dates mean. So that way people will see it's the quality date. You're not throwing away food you don't need that you can still eat. Okay, so let's talk about the technical solutions. So, skip. Next one. Thank you. Okay, so this is the Food for All app. So what this app does is it will get people in touch with local restaurants that have overstocked food. And what they'll be able to do is they'll be able to buy this food 50 to 80% off. So this is a solution where everybody wins, as it gives people the solution where people who don't have a lot of money, they can buy food at a cheap price. Restaurants can also make money on the food instead of just having to throw it away, and it could be completely wasted for everybody. Next slide, I think. All right, another app that was created is the Food Cowboy app. Now what this app does is it'll get charities in touch with a local food truck, say, that needs to get rid of food quick. Like, let's say it breaks down or its refrigerator malfunctions, right? So what they'll have to do is it'll get them in charge with the local charities. This app will send off an alarm to the local charities that there's a food truck nearby that needs to get rid of food. They'll be able to take the food and get rid of it so it isn't wasted. Okay, next slide. Okay, so the primary use of our device, as mentioned before, will be in the kitchen. Okay, so our device will be in the kitchen, so let's talk about, okay. So here's the situation that happened to me a few months ago. What happened was I was going to eat my lunch one time. I was going to eat some eggs for lunch, but what happened was since I usually make my own lunch, but on this particular day my mom said there were some eggs left over in the refrigerator. So what I did was I went in to eat the eggs, and I opened them up, I started to eat them, and what I noticed was that they were pretty gray inside, so not very edible. I wasn't able to finish my lunch in spite of trying to wash it down and everything. It just wasn't good enough. And the reason I mention this is because the eggs, there was nothing inherently wrong with it from opening it up. There was nothing, it didn't smell bad, it didn't look bad. Even starting to eat it, I didn't notice it quite as well, but it was evident that, after eating for a while, that there was something wrong with it. So this ties into our device, because what our device is going to do is it's not going to monitor the condition of the food. It's going to monitor just the time you left it in the refrigerator. So it's good for that. Next slide. Okay, so let's say we have a user named Jessica who is throwing away food that she thinks is bad, but she's throwing away food because she can't keep track of it. What we've developed is a device that'll keep track of all her foods and the time it's been in the refrigerator. All she'll have to do is push a button to say when she's putting food in, and then push a button to say the category of the food which she's putting into the refrigerator. So what Jessica will be able to do now is keep track of the food. This device will give her an alarm on when her food has been in the refrigerator for a little too long than is convenient. So what it won't do is monitor when the food is expired. Like we said, it's not monitoring the condition. It's only giving you an alarm when it's been in there for a little longer than is necessary. So what that'll do is that'll give people the convenience of being able to eat their food even after the alarm goes off. It's just something that's monitoring the food. It's just something that'll monitor the time that it's been in there. Okay. So another convenience of our product is it's portable. It'll be a small device that can go right on your refrigerator, but Jessica will be able to take it with her places, like if she wants to go on a business trip or if she wants to go on vacation and she's going to bring food with her, she'll be able to monitor that food too. So it's just an added convenience. Okay, so lastly, what a possibility of our device is that we're going to be marketing it to bigger businesses, stores. Although while over 40% of food is wasted in the home, this can also be a problem in stores and stuff. So what we'll want to do is that would be obviously more something to look into down the road, making our project bigger, making it more convenient. So, and stores already have their ways to keep track of food waste. They have computerized systems to keep track of it through logs. They also have stickers to label the food and do it with inventory. But what this device can do is you can just look at your system and it'll have a light saying whether it's good or whether it's bad. And it's that simple. Like, it'll have a red light saying your food's been in there for too long, or it'll have a green light saying your food is still good. So people won't have to check through logs and walk through aisles and everything else, take all that time consuming. So the technical creation of our device was, we created our device through using the engineering design cycle, and Edwin here is going to tell you all about that.
Thanks, guys. So the engineering design cycle can be applied to pretty much any problem. And it's what all of us have done. We've all taken these 8 steps and used that to model what our solution was going to be like. So we've already talked about the amount of waste that's being generated every year. On average, $1,500 of food is wasted per family per year. And now, I know everyone in this room is probably thinking, yeah, I threw something out maybe this last month. So we wanted to be able to make a tracker that can do everything automatically for you. It's something that could be taken with you wherever you go. It can be used while you're at the grocery store, or when you come back from the grocery store, or any time in between. So it's something that should be with you at all times, like a cell phone. So our device is going to emulate a signal coming in from a router. So this device should be able to, if you look at the process of our PIPO, it should be able to add things, use things, and program how long you want it in there for before it gives you an alarm. So there were a lot of things that we needed to think about here. The very first thing was power. It needed to have some kind of rechargeable battery that could give us levels of about 5 volts or 3.3 volts. And the output had to be some kind of screen with some kind of indicator LED. So the very first thing we said was, how are we going to get all this logic into a small device? Well, here's the ATmega 328P microcontroller. And for the layperson, you see the port B, port C, and port D here. That's sort of similar to plugging in a device to a USB port. So every port can be programmed as an input or an output. And in total, we have about 20 pins that we can use for our device per microcontroller. So our first schematic called for 28 total pins. And in order to accommodate all these pins, we had to get 2 microcontrollers and make them talk to each other, essentially. So this is going to require 2 different programs and too much space. So here's an example of what we did to try to reduce some of those inputs. We used 1 analog input instead of 5 digital inputs, and we're able to save some space there. Here are the equations that we used to make sure that our resistors were correct. So our first design met all of our requirements. First, we used a 7-segment, 4-digit display, like the kind that you see on an alarm clock. And now this was great, but it didn't really meet all of our end requirements. We wanted to be able to see exactly what food was in which category, and since this didn't have any letters, then we couldn't really use it for our end device. So in order to do that, actually, let me go back. In order to do that, what we did was we took those 4 cables that you see there, and we upgraded the screen to something that uses those same exact 4 cables using some serial connection that I'll elaborate on later. So here's our second schematic, and this is the final design that we used. In this case, there were only 10 pins that were used, and that's reduced from 28 pins. We were able to, once we had this set up, we could program it in circuit and reprogram it and just focus on writing the code. So here's the screen with today's date, January 6th. So let's talk about the circuit battery life. If this is going to be sitting on your fridge, you don't want it to just die in the middle of the night. So the battery life for any device is dependent on the capacity of your battery, which is rated in milliamp hours normally. So this is based on a 700 milliamp hour battery. And as you can see, if we have about 100 milliamps running through the current, then this thing will last 7 hours. So our goal was to keep the amount of current in our circuit below 100 milliamps. A regular smartphone, a modern smartphone, can have up to about 4,000 milliamp hours in that battery. So this is our circuit. We're taking the measurement of the total current here. That's 61 milliamps. So if you take the capacity of the battery and divide it by 61 milliamps, you'll get the amount of hours that it'll last before the battery dies. So if you see the 2,000 milliamp hour battery will last about 33 hours, and a modern cell phone battery will last 66 hours before you need to charge it. So here's our final design. This is before we did all the hard wiring. We had to solder this ourselves and figure out how to fit everything inside the box, which was a major challenge, but we got it done. And if everyone wants to step up, and I'll show a demonstration of our device.
Computer.
She's just adjusting the screen, making sure the connections are good. But those connections that she's touching right now are the serial connections. And those serial connections can be used to power or to control any serial device. We're planning on upgrading this to a touch screen because we want it to be modern and we want it to be usable and familiar. And those touch screens can use those serial connections. So this is ready to go once we just reprogram it. So let's flip it on. Sorry, technical difficulties. But we have two models here. And the first model that Cindy is holding is just the sped up version of what we were going to show here. But this other version is the breadboard version, and that's going to be available later on for all of you to touch and prod. So here's the screen. I don't know if anybody can see, but this is a 16 by 2 LCD screen, and we just use this for cost effectiveness, and because we were able to store everything on this microcontroller, the display wasn't exactly super essential. But this here is emulating a signal coming in from a router. So the router is going to tell it to either add something, use something, or reprogram it. So here I'm going to demonstrate pressing the first button. Did everybody see that? It says that your chicken now has 3. So every time you press a button, it will increment. And if we wait, well, this is not the sped up version, but in about a week, the alarm would go off. So now Cindy has fixed the issue. Do you want to go ahead and press the first button?
Okay.
Set it to use mode.
You see?
Yeah, what do you say?
Yeah. You see?
Oh, you have it on use.
Yeah.
Okay, so now our meat has one thing in the fridge. So that could be a package of chicken, a package of beef, whatever. That date that it indicated, this alarm should go off. And now if we press the bottom button, a completely different thing. Dairy says it has something in there, and on the 17th day, the red indicator LED will go off. And now you might be thinking, well, maybe I don't want to store something in there for a week. Maybe I want to do it for 10 days. So we have a program function here. If we flip the switch, there's the first LED alarm. So if we flip the switch, it's going to ask you for the category. Now I want to reprogram maybe this, this second one here. Now I input the amount of time that I want it to last for. So can somebody give me a number?
2.
2. 1, 2. Then we press the bottom button to exit. And now this second LED is programmed for 2 days. So right now we're on day number 22. We press the button. It should say, oh, whoops, I have it on the wrong side. It expires on the 25th, and the day I pressed it was the 23rd. So now there's the alarm going off.
Wow.
And the last thing, if we set the switch to the middle, it will show you all the categories with all of the food in those categories. Now the very last thing, which I will not demonstrate right now, but these connections here, these 6 cables are the programming cables. And we can use Atmel Studio version 7 to wire this up to a computer and reprogram it. So when we're ready to upgrade to a touchscreen, that's something that's very easy to do.
Oh, so you'll be able to change whatever you want the categories to be.
Yep.
All right, let's have a seat. Yeah, where's Tupperware, right? Smart Tupperware right now integrated with computer.
Now lastly, that circuit card was made by hand. So it was completely by hand, 100% soldered using wire. And as you can see, that was sensitive. When Cindy was turning it on, for some reason it didn't work. She had to check all the connections, make sure it was good. This here is the printed circuit board version of that circuit. We can send this off to a manufacturer to get it made for about $5 a board, is what I was quoted at. There's another one I found for $2 a board. So if we shop around and find the cheapest manufacturer, we can get this circuit professionally made, and it'll be much smaller, and we'll have room for other things once we reduce it to a surface mount device. And the current manufacturer price for 100 at $5.14 per board, it's $24.19 to manufacture that box over there.
I would like to give a special thanks to all the people who involved in our journey to make this possible. Professor Catano, the project guidance, Professor Asker, who helped us with the code advisement, and Professor Balaki, the power supply option, and Professor Yakini, the webmost voice dissection, and also the 2 professors, the speech professor, Professor Lozon and Professor Palin, and James Kingston, the research assistant, and Lane Rachel, the research assistant in the library, and Sean Raffrey and Damon Wilson, the box cutter and manufacturing, and Darcy White, the food catering, and thanks to our friends and family. Thanks. Joey?
Thank you all for coming. Is there any questions?
Take your seats, guys. A round of applause for circuit caters. Very practical solution. I think the problem that they did cite is a big problem, right? We actually don't see the food waste, but the food waste is contributing to climate change, greenhouse gases. Have a seat. Let's limit Q&A to 5 minutes. Have technical questions, business questions, user questions, practical questions, questions from investors or future users of Computer. Engineer Kyle, Investor Kyle.
First of all, excellent presentation. Now, when you go to field device, what controller are you going to be using?
The AT Mega 328P.
Is that what you're using right now?
Yes. Now there are several versions of, well, there are several different microcontrollers, and we were actually looking at a completely different one that was much bigger. It had 4 ports instead of 3, and 8 bits per port instead of 6 and 7 for some of them. And if we want to have other circuits in there, say, for example, some kind of circuit that allows us to connect to the Ethernet, or something else that will better control the touchscreen and give it nice graphic user interfaces, then we have room on the board once we make everything surface mount.
Engineer Purcell. Yeah.
I apologize if I missed it because I was behind the poll, but Right now, your device is being powered by batteries, is that correct?
Yes.
Okay, are there plans to make it a little bit more permanent and continuous? Because if I have one more device that I have to remember to charge every 36 hours, is what I heard, right? That we're gonna have an issue.
Every 66 hours.
66, but I still have to recharge it, so therefore, you know, if this is something that I'm gonna be using continuously, periodically, or whatnot, it should be self-running.
I completely agree with you. And right now, what Joey talked about was the $4,500 fridge. And that fridge has something built into it. So our device could use a similar functionality to what phones have, where you can just place them on a wireless charger and just leave it there. So since this is going to be mounted on the fridge using a magnetic backing, we could accommodate some kind of constant charging capability. Right now, we can leave it plugged in to a USB cord, but I know that might be inconvenient for some people, and that could be something that we work on in the future.
Any question? Battery life. Questions, especially on the practical use, especially if you go shopping. Go ahead.
Well, right now we can monitor only 5, but as I mentioned, like we could in the future market this to stores in the future. So there's no limit to actually how big this device can be. It's just that we keep it small because it'll go in your refrigerator. So right now it's only 5 categories, but we could expand it to as many as necessary. Like that could be something like you call in for a design, like it could be a designer device even.
In that case, we're going to get rid of the LEDs and maybe monitors. Maybe have one LED and then the app will be able to allow the user to go inside the app what food it is.
Yeah.
Exactly. And the end goal was to emulate a signal coming in from a router. And the reason for that is because we want to be able to use your favorite app to control this device. So on your app, you could type in however many categories you want, however many foods you want, and whatever date you want the alarm to go off.
SKA Seth has a question for secretaries.
You kind of just answered it, but I was going to ask, what happens if you buy a dozen eggs and you boil half of them and you leave the other half for breakfast or something? Is there a way, like you said, you can add as many categories as you want on your phone, so that kind of answers the question.
Fresh Kubacher? Yep.
How would it self-adjust for, say, an extended power outage that case in spoilage of food?
Good question. That's a great question. Well, this is an inventory tracker. And unfortunately, that would be out of the user's hands and the device's hands.
Yeah, like if it was running on its own battery, it would still work, but obviously during a power outage, it would be going out. But yeah, but hopefully people wouldn't necessarily rely on a device anyway to monitor their food during a power outage. So I think we were more counting on just normal conditions, but that would be something to look at in the future.
For future redesign, right? A serial input, that's a temperature sensor perhaps, just to know that the fridge is no longer working. Right. So you got it, right? A couple more questions for the secretaries. Go ahead.
You quoted a $25 price for your product, cost, I should say, for your product, and you say communicates with a router. Is that wireless? Is the wireless component built in, or is that a future?
That's a future.
That would be a future design, so that would be an additional cost.
Yes.
But that's part of your, and since I'm playing retailer,
Yes.
so how would you approach me as the retailer? Like, why would I want to sell it to consumers?
He is Costco. Professor Rodriguez is Costco.
You want to talk about that?
Why do you want to sell it?
Well, so we would ideally be targeting the consumer, and the consumer does not want to be spending over $1,000 per year on food waste, and if they can save that much money by buying a $75 thing, I'm sure many people would agree that that's a good investment.
Yeah, and another thing we could look at is we could include this device as part of our refrigerators. Maybe we could partner with a refrigerator company and have them sell it for us as well. Like that could be part of it too.
Yeah, focus on the value, right? The value pitch, plus and value pitch. One more question for circuiteers.
How much is the you can sell this device for?
Well, right
Are
now,
we thinking like 75?
yeah,
Yes.
right now about 75.
$75.
I'm a competitor from China, we just made it for 35.
Fresh Leone. Fresh from China. I think from a volume production, it would be cheaper. Yeah. All right. One final question, Engineer Andres.
So let's say you were doing production for this. What would be your lead times for getting all your parts and stuff like that? Like how long would it take from when you started to when you ended to like start to finish?
That's something that would have to be ironed out. But the longest component, the longest delivery time for building this, us personally, was about 2 weeks.
Good. Before we wrap up Circuiteers Food Management Solution, raise your hands if you've always had problems managing refrigerator stuff. I've always thrown out eggs, vegetables all the time, and hopefully we can have a prototype of this soon in production. You have your prototype? Hopefully we can have something in production soon so we can prove it to everybody. And if you give away 1,000 of them, they'll keep on coming back for 1,000 more. All right, thank you, Circuiteers. Impressive. Thank you, Computer. Awareness for food waste and solutions to food waste using an inventory tracker solution. And I love the demo. I love the demo. And thank you for educating us about food waste. All right, thank you so much. Once again, we have another company coming up. It's addressing the second level of Maslow's hierarchy of needs, which is safety. We have DFS Solutions. A round of applause for Engineers Scott, Dave, and Frank. DFS Solutions.
Good afternoon, ladies and gentlemen. On behalf of everyone at DFS Solutions, I would like to thank you for joining us today. My name is Frank Sheehan. I'm the president and CEO of DFS Solutions. Today, we're going to showcase a brand new product that we've been working on, and we think it will make your deliveries more secure. Our team has been working overtime on this, and we're really excited to show it off today. But first, we want to introduce ourselves and give you some updates on our current product, Porch Watch.
Good afternoon. Last year we started selling our Porch Watch camera system. In the past 12 months we had $770,000 worth of sales, of which $231,000 were profits. Due to this grand success that we had there, we decided to expand our product line into a new product. Here to tell us more about it is our President and CEO, Frank Sheehan. Talk about our next innovation.
All right, so like Dave said, we do have our existing product on the market already. It's called Porch Watch. Again, we have Dave, who is our CFO, our Chief Financial Officer. We have Scott over here, who is our Senior Vice President of Research and Designs. And of course, DFS Solutions is part of the Cartano Industries conglomerate of companies. We are located in beautiful Randolph, New Jersey. And why did we choose Randolph? Well, we chose that because of its close proximity to key infrastructure, resources, major client markets being less than 30 minutes out of New York City. And we also have access to a diverse pool of talent, and they're highly skilled, and they're all right here in the tri-state area looking for work. DFS Solutions, we pride ourselves on solving life's problems so you don't have to. And life's moments are precious. We don't want you to miss any of them worrying about the small stuff. So that's why we're taking that worry away from you, focusing on that so you can enjoy your life as you intended. I'll just go over this again. I know Dave mentioned it. Porch Watch sales since launch, we've had $770,000 worth of sales. which equates to around $231,000 in profit. I do apologize that small text. I had it larger, I guess it never saved. And this is a slight faux pas. So what you should be seeing here is our my computer. There it goes. Technical difficulties, everyone. I do apologize for the technical difficulties. All right. So $770,000, isn't that great? It's a really incredible figure. We are very proud of how our product is doing. And as I mentioned, we do pride ourselves in solving life's problems, so you don't have to. So today, we are ready to expand our product line and release a brand new product. Now, this product is still in development, and it's on target for an on-time launch, but we need a few more dollars in funding to get it across the finish line. A few months ago, we were approached by our parent company, Arduino Industries, with the request to identify a problem in society and identify and develop a solution for it. So the only requirement is that it needed to satisfy a category in Maslow's hierarchy of needs. After long weeks and days, nights discussing, debating over what we would choose, we decided to focus on package theft, more commonly known as porch pirates.
Yeah.
All right, so I'm going to tell you a story, almost set the stage. Imagine that you are shopping for a brand new camera, and you've spent weeks, months, long nights, hours researching and researching and researching and looking for the best price, finding the best model, Canon versus Nikon, DSLR versus mirrorless, Sony versus any other point-and-shoot brand. You couldn't decide, and you finally have decided that you are going to pick a camera. And you searched for the best deal now. Oh, this one looks good. So now you're ready to purchase it. All that's left to do is click buy now and buy it now. Now you just got to wait for it to arrive, right? We're all familiar with Amazon. And if you're an Amazon Prime subscriber, it would arrive within 2 days. Usually they'll also send you a notification if you use their app that it's been delivered. So you get that notification and you're very excited. You run to your door, you open it up, you're expecting to see that familiar blue and brown tape box, and what happens? Well, it's not there. So now what? 1 in 12 Americans have had a package stolen. And this is a problem, because you don't get your stuff. It affects your bottom line. It affects the manufacturer's bottom line, because now they have to sell more product, or not even sell it, they have to give you more product. They're not even making a profit from it. It affects the retailer's bottom line, because they're now replacing your stolen product. It affects the shipping company's bottom line, because the shipping company is going to now have to re-deliver a product that they're not really getting any more money on. We don't want that to happen. There was a survey done of about 1,000 shoppers, and of that 1,000 shoppers, 42% of those shoppers reported that they need a non-visible area in their home, on their property, for their packages to be delivered. Why do they need this area? Because of the fear that someone is going to walk up and steal their package in the middle of the day in broad daylight. Those same 1,000 shoppers, 41% of them now no longer say that they're going to purchase online because of that theft. Again, affecting the bottom line, something we don't want that to happen. This is a big deal, especially when 92% of those 1,000 shoppers want stuff delivered to their home. Online shopping should be fun and convenient, not tedious and fearful. So what is the solution? We did some research and we found there are some options out there for you. You could have a giant red toolbox right by your front door that has a lock, and the delivery company would drop off the box and lock it, but those are very big and bulky. You could also find a drawstring backpack that has a lock and securely wrap it around your door for your delivery company to drop the package inside it and lock it up. The only problem with a giant lockbox or a hanging bag is they are easy targets for theft, and they clutter up your front porch. It's an eyesore on your front door. We can do it better. When we set out to design this product, we identified 3 requirements. The first one being this product needs to detect and alert when a package is stolen. 90% of convicted burglars said if they did encounter an alarm, they would choose not to attack that home. And this is according to reports from the FBI National Burglar and Fire Association. Requirement number 2, this product needs to be discreet and unobtrusive. We want your front porch to look exactly as the way you intended it to look. This is what your porch should look like. There's no boxes, there's no bags, it's just your design. And the third requirement, it needs to be low in cost. Everyone should be able to afford package security, and no one should be priced out of that market. This is what we hope will happen. As we advance this category, this definitely will happen. Since we are kind of in the early stages, we're not quite there yet, but we do want the cost to go down. So our 3 requirements: detect and alert when a package is stolen, be discreet and unobtrusive, and be low in cost. I am pleased to announce that we, as a company, have developed a solution that we feel meets these requirements. And to tell you more about it, I would like to invite our Senior Vice President of Research and Design, Scott Trost, to tell us. Scott?
Thank you, Frank. Oh, can you guys hear me? Is that better? There you go. Okay, so today I'm here to tell you about Delivery Guard. Delivery Guard is our product to help keep your packages secure. It's a theft deterring doormat designed to bring you peace of mind while you shop online. So normally we would be asking you guys to come up for a little demo, but one of the main purposes of Delivery Guard is that it's undetectable when it's at your doorstep. So there's not much to see up here during the presentation. The only thing I can show you is this, which would hang next to your doorbell. Nothing that is too obvious or anything like that. And it's also easy to install. Now, before I show you guys the demonstration, I am going to warn you, it will cause a loud noise. It needs to be effective, so unfortunately there's no getting around that, but just a fair warning. Okay, so now the switch that we would be designing, which is what I will get into, and that's what we're asking for in development, would activate the system as soon as the package is detected, as soon as the delivery person puts it on. But for this purposes, I have a prototype, so I'm just going to arm it using the device itself. Okay, so the package is on, and then as soon as a would-be thief would take the package off, the alarm would go off. Now, putting the package back or anything like that won't stop the alarm. The alarm will continue to go off As you can see by our research, that should cause the thief to drop the package or at least alert a neighbor or something like that. Someone will see what happened. It's a safer alternative. There is also a kill switch, as I showed you with the manual operation, and that's because after you've worked a long day at work, the last thing you want to do is pick up your package and hear that noise. So you do need to be able to disable it yourself. Now, I have a block diagram of the circuit right now. The custom switch would be at the top, and that's connected to a 9-volt battery. We chose a 9-volt battery because it's very common to have in your house. It's no different than changing a smoke detector. It runs for a long time. It's not obviously going to stay armed always, but just when you're expecting a delivery. Now this would go into the existing delivery guard circuit that I have developed. I chose not to give you guys an exact diagram because it is intellectual property of our company, but I can tell you it involves a digital electronic switch. The switch would need to be an input going from high to low, and this would activate a D flip-flop type switch, and that would activate the circuit. Therefore, the alarm is not on when there's no package, but as soon as it senses a package and then goes back to low is when the alarm would activate. This goes into the alarm system, which has been developed and is fully ready to go, and that completes the product. Now, here is a design of how we would like it to look after the switch is developed. We want the switch to be part of the mat and go directly underneath it. Again, one of our main concerns is it not being detectable. It needs to be look just like any other house to a thief. So that would sit there, and that would fully detect any package that is put on the mat. I'm sure you guys are aware when you order stuff online, almost every company now has special instructions for the delivery driver. All you would need to say is to please put the package on top of the mat, and the delivery driver themselves don't need to know that it's an alarm or anything like that. Okay, so some features of it. It's a thin design. Again, sticking with the theme of not being able to tell that there's a system in place for the thief. It's ultra sensitive. With some other switches, we were able to get it down to, I believe, packages almost under 1 pound can set the sensor that we were using off. So combining that sensor with a switch that we would develop, that would be our target range for how small of a package that could set this off. Independent security. Now, as we have mentioned, we do have another product that is also security. It's called Porch Watch. Some of you may have surmised that that is a camera that watches your porch. This would be an independent system from that, because we chose to do it that way because we don't want one system to run out of batteries or go down and then kill the other system that otherwise would be a perfectly well-designed system. So they run independently, which doubles your chance, for one of them to work. Low power, as I talked about, we chose a 9-volt battery because we know that they last a long time. In something that's always on, like a smoke detector, this would be the exact same principle of low power. It's just waiting for the package to get there. Okay, so alarm features, as you can tell, it is loud. It is louder than a jackhammer, as tested by us. Battery operated, which I went over, and the setup is easy. Plug a 9-volt battery in and hang it right next to your doorbell. Or if you're one of our former customers, right next to your porch watch. Okay, so I'm going to go back to David, our CFO. He's going to tell you a little bit about our price points and some margins that we're hoping to hit.
Okay, thank you. Based on our research there, we want to go reach a $129.99 price point there per unit, so it gives us a 34% profit. And today we are asking for a $200,000 investment, for which we will give you a 10% stake equity in our company. And anything you'd like to add there, Scott?
I will take it back, Scott. Not a problem. It's okay. So that is Delivery Guard. We hope to retail it for $129.99. So I go back to our checklist. We had 3 requirements: detect and alert when a package is stolen, be discreet and unobtrusive, and be low in cost. With our 100 decibel and plus audible alarm and the pressure sensitive mat, it will detect and alert when a package is stolen. It can fit under your existing doormat and make your front porch exactly the way you design it. There's no bulky safes, there's no bulky bags. It is discreet and unobtrusive. And at a retail price of $129.99, we hope that it will be low in cost. This is cheaper than a very big, giant, bulky safe, and it is the peace of mind that your doorstep is the way you intend it to be.
Okay.
We will.
I just wanted to add one thing. I did forget to show you. I did mention we have an existing circuit. This is it, and this is the black box that it would be held in. And this, obviously easy to hide somewhere on your porch, right underneath your door, and adds to the theme of not being easily detectable. But we did need a weatherproof box to hold the circuit, obviously.
Thank you, Scott. Weather resistance is a very extra positive feature as well. We'll take your questions in a moment, but before we do that, we'd like to thank the several members of the staff and departments here at CCM to make this day possible. Without them, we would not look as good as we do today. And certainly all of our products and all the other companies here could not do it without you all. So thank you very much, and thank you for coming today. This concludes our presentation.
All right, before we take the first questions, as you can see, there's something very simple that hasn't been done yet, right? If you think about it, there's a Ring doorbell, there's that porch solution. At the end of the day, has anyone thought of the mat being the alert or the switch system? All right, questions for DFS Solutions. Investor John Urgola.
Okay, so I'm just curious, how would it arm? You said it's once something's placed down, right?
Yes.
So is there a delay?
No, there's not. As soon as you arm the circuit, which you would do before going to work or going out of the house, the pad is in a low state. As soon as the package is placed, it will be in a high state. As soon as it senses the package, immediately with it going to low, we'll activate the flip-flop circuit that I designed, and that will give power to the alarm and set it off.
So is there a concern that, like, I'm the delivery man, right? And I place it down, and then I realize I have another package that's not going to fit on here, so I pick this up and move it over. Is that going to set the alarm off? Is there, like, maybe an idea to have a delay, like a 5-minute delay before it arms?
No, we didn't come across that in our testing. You know, that's probably something that we should implement and something we may have picked up on through internal testing. But right now we're obviously still in the research and development stage of the switch. So assuming we would have picked that up, that would be our solution of a delay, because the chances of a thief coming within the first 5 minutes is pretty low.
So there is also research out there that has, and they have done studies where the thief sometimes trails the delivery truck. So as soon as they put the package down, they just come right in behind it and pick it up. So we would have to do further testing to ideally determine what that delay would be.
And forgive my lack of technical understanding. It's going to recognize a change in weight or only a decrease in weight?
A change. Well, a change or the decrease would be the change. Adding pressure to it would still activate, because a 30-pound package, a 1-pound package, it doesn't matter. As long as there's a package is all that it needs to be a high signal.
So, like, I'm sorry, I just want to make sure I understand. So I put down a 5-pound package, and now I put down a 10-pound package. That's not going to set it off because it's not a decrease?
No.
So then what about if my neighbor's cat ran across me?
Well,
It's a practical question, yeah.
That is a practical question. This is a circuit that's not always armed. It's only armed on the days that you would be expecting a delivery. So the chances of the cat running across, I mean, it is a product that's out in the real world and it's supposed to detect something while you're not there. There's always going to be some sort of cases where things can go wrong. but 90% of the time, it's going to be able to help you get your package safely.
And if it's anything like my cat, it would only do that once.
Yeah, the alarm would prevent it from happening again.
Dr. McCoach?
Yeah, how long would the alarm go for?
Until the battery ran out. We didn't test it to drain a battery, but hours.
So it's going to be screaming in the neighborhood for hours? I guess someone would, I mean, if your house is isolated, it could be an issue.
And this ultimately could be a connected device, right?
Yeah.
That's a good question, though, since it could be disturbing the neighbors as well.
And we obviously are working on getting revision 1 out. That could also be a feature for revision 2 where it's on a timer or it could alert to your smartphone or other smart device.
Yeah, but it going for that long isn't necessarily a bad thing, because if it's bothering a neighbor, chances are they would call someone, and that's the type of attention that we're looking to draw.
That's true. Engineer Edwin?
So I noticed you have it underneath the doormat.
Yes.
I was wondering how much pressure can I withstand? Because on, like, say, a rainy day when I have mud on my shoes, can I step on the mat and scrape my boots off on there? Or?
Well, if you were going to step on the mat, you would disarm the circuit because you don't want to set it off, because walking on it and then picking your feet up would set it off itself. Okay. So it functions as a normal doormat outside of that.
Question. It kind of expanding on his, like, let's say you do that, but you're 250 pounds. Is it going to destroy the product itself? Like, what is the weight limit?
That's some.
Official mat was 350 that we were working with.
Yeah, so initially we had a 350-pound limit. That is some of the issues that we ran into when we were trying to develop a switch that would satisfy our needs. But we just ended up running out of some time, even after putting in overtime, to get a switch working for you guys today. And that's why we would need the investment for extra funding to research such a switch that would do that.
So 2 more questions. Engineer Andres?
So what's stopping, say, a thief coming over there, placing like a lock that's heavy, and then taking the package off of that?
Doing Indiana Jones kind of thing?
We all know that scene, right?
Yeah. As you remember, one of our main themes is that you're not supposed to know that there's a pad underneath it. I mean, I guess if a thief was savvy enough to immediately detect that there was a pressure there, they could, in theory, do that. But our goal is to make it so it's not obvious that there's a system in place, and it just looks like a normal welcome mat.
And that's part of the value pitch.
Does it work in conjunction with the camera? You talked about a camera system. Does it work in conjunction?
The camera system is separate. You want to take this one first?
Well, so first, kind of backtrack and respond to that other question. Having a security system, period, will put you better off than not having it. And of course, I mean, bank robberies happen, you know, they're not uncommon, and they have very high security as well. So we can't prevent every theft, but if we can prevent a majority of the thefts, then we are doing our job. To address your question, you just would mind repeating it?
Yeah, does it work in conjunction with the camera system? You said you had a camera system also. Does it work in conjunction with that?
So the camera system, which we didn't go into as much, works off of a proximity sensor. So if someone is near, it would turn on the camera and record it. So if somebody, it doesn't directly interface with the camera, but if someone were to take your package and you had the camera would be recording because that proximity field has been activated and is starting to record.
Yeah, so the reason why we didn't necessarily go too much into the camera is because that is an existing product that we already have out there. This is a standalone product. They do work well together, but it's not necessary to have both. We're selling them each individually. Obviously, they make a great pair, but it's not necessary.
All right. Final question? Go ahead, sir.
Yes, you said the price was $129.
Mm-hmm.
So what is your cost?
It'd be somewhat less than 129. I'd rather not get in details there. You'd be about a third of that.
Yeah, we have a profit margin of 34%. So that would be something that we would aim with the research and development to keep our switch at that cost. The cost that we're looking for is around $37 to $39 to make and ship, and then the retail price would be $129, giving us that 34% margin that we talked about on the slide.
Okay. All right. I think we're doing fairly well with time. Once again, let's do like a little survey here. Has anyone here ordered from Amazon or online? Raise your hands. All right. The DFS Solutions on to something. Has anyone lost any package? I lost a $2,000 guitar in front of my house. Never recovered. Got $300 in insurance back. So hopefully DFS Solutions continue with their efforts to complement their porch solution so that we can have a peaceful online shopping experience. Thank you so much, DFS Solutions.
Thank you, guys.
All right. We'll do further well with time. We want to wrap up around 5:40. Our fourth company, fourth team, please come on up. MJ Technologies. And this one is really the elephant in the room from a problem standpoint. I don't want to steal their thunder, but please do stick for the next 30 minutes for their presentation. MJ Technologies, please.
All right, hello everyone and welcome. We'd like to introduce everyone here to our company, MJ Technologies. My name is Michael Del Magro and I'm the president. And this is my partner, Juan Victoria, vice president. Before we get into talking about our issue that we're going to present in future slides, we would like to talk more about our company.
Can everybody hear me? Oh, okay. I don't think I'm going to need that.
Okay.
Okay. Just to summarize who MJ Technology is, MJ Technology is a privately owned business. The founders are me and my partner here, Michael. We have also aligned ourselves with Cartano Industries. Hi. Okay. Our primary goal is to provide innovative services. We try to offer superior support.
Yes.
That exceeds the products of our customers' requirements. What else is there? Also, we also, sorry.
It's okay. Yeah. You can read off the paper.
No,
You're good.
thank you.
Yeah. You're good.
Oh, as I was saying, our target audiences include military, automotive, aerospace, and commercial industries. You can go up there.
All right.
That's basically it.
MJ Technologies is registered with the state of New Jersey. Our location is in Paterson, New Jersey. The scope of our organization is engineering, design, development, and manufacturing of circuit card assemblies, electrical and mechanical assemblies, and customized test equipment for military, commercial, aerospace, and other industries. And we'll get into why we chose Paterson in a little bit. The reason why we chose Paterson as our location for our company is New Jersey offers an urban enterprise zone program, reduced sales tax, tax-free purchases, financial assistance, and other benefits. And this is your next slide.
Okay. So with any business, there obviously comes a lot of risks, both internally and externally. We created a chart here to show what some of those issues could be. For instance, an increased customer requirement. That leads to a strain between both internally and externally because, for instance, if a customer wants more requirements, we're going to have to go out of our way to satisfy them more. It's also an issue for them because it could mean a delay, for instance, on how hard we're working or how quickly we manage to get it out to them. We can continue after that.
All right. In addition to operational risk, we also identified risk and opportunity with interested parties. Here you're going to see some examples. Interested party would be on the left-hand side with the risk and opportunity on the right-hand side as you're looking at it. And it goes from employees, customers, let's go to the next slide. Community. An example of risk, it would be pollution during manufacturing of a product, so it's a big taboo. The next one is suppliers and vendors. Obviously, we need to get suppliers and we need to worry about on-time delivery so that we can meet our delivery to our customers. And then regulatory, many other governmental issues or requirements that we have to meet. This is the big one. Now, as interesting and pretty as this pyramid chart is, you're probably starting to wonder, what does the Maslow Pyramid have to do with our business? Maslow's hierarchy of needs is a theory of human motivations, suggesting that once certain needs are met, people are not satisfied with the present condition, but instead develop to new higher order needs. And you can see here they start from the psychological and move all the way up to self-actualization. And you can see in the pyramid itself examples of each one, each step moving up. Today, corporations Today, corporations are being expected more and more to comply to higher standards of ethics, and that includes ensuring employee needs are truly met. And as a business leader, striving to meet our team's needs doesn't only make sense morally, but it's also for good financial sense, and it's also helps with our risk mitigation and with regards to employee retention. Not only that we fully support employee self-actualization, but we strive for workplace actualization, whereas the company as a whole can focus on morality, creativity, and problem solving, which is the top tier of the Maslow. All right, let's go to the next slide. Problem.
All right. So I can all assure you, some of you guys are asking yourselves, why are we all here listening to this? You see, the big issue here in America right now is cell phone dependency, or technological reliance, as I'd like to call it. So America, over the years, they've developed a psychological issue known as nomophobia. What that means is all of us have to be on our phones for a certain amount of time, or for an excessive amount of time. For instance, me, I don't consider myself to have nomophobia, even though I'm on it 24/7. As much as we hate to admit it, some of us do have nomophobia. For instance, below here there are some statistics about how people handle this type of addictions and how they've been impacted. The first one is Americans spend at least an average of 5 hours a day browsing on their phones. This is a fact. Me being an American, I can say I can't really relate to this. For me, it's at least 6 to 7 hours I'm browsing. That's the truth. The way it impacts us is the fact that it does kill a lot of our productivity. For instance, in school, at work, here, I can see some people that were on their phone earlier today. It's just a way to, how would I describe it? It impacts us because we can't really get our work done, and you can kind of see that in the market and in, next slide. You can just go. So that leads to, what if there was a device that could at least bring a reduction to that? A device that could at least stop me from going 7 hours a day, or can regulate the amount of times that I check it, for instance, while I'm doing my work. Okay? What if there was a device that, for instance, we could have in our classrooms and every student could just put there while we're during the lecture? For instance, what else? Also at work and in the car, to stop us from texting on our phones. Next slide. Oh, thank you. So what MJ has created is a device called CARD. It's called the Cell Phone Access Reduction Device, for short. So what it consists is of two sensors. One sensor for the phone, one sensor for the case. They will act as alarms to indicate whenever someone goes on their phone when they're not supposed to. So for instance, if I have to take a test and I want to be on my phone, or if I have to get my homework done while I'm at my job, I will place my phone there while I'm doing my job. If I get a text or I want to send out a tweet or I feel like scrolling, the minute I look at my phone, it's immediately, the alarm is going to go off. And a full disclosure, this is a sound that you don't want to hear. Once I heard it, I wanted to put my phone in there for the remaining day.
Same here, yeah.
We'll move on to
Oh, you can move on.
All right, this is the basic function block diagram for our circuit, or for our system, I should say. We have our power requirement, we have our two inputs, we have our process, and we have our outputs. We'll get into more detail later on, but essentially that's pretty much the basics of it. This is me too, right? All right, it was already previously mentioned, but the target market for the card system is for employees, or for employers and schools where utmost attention and focus is required. The way it works is quite simple. The manager or the teacher instructs the employee or student to place their phone on top of the first sensor and will power on the card system. Afterwards, the cover of the case engages with the second sensor, and this will fully activate the card system. Whenever the cover is open, the first alarm will buzzer, the buzzer will go off and stay until the cover is closed again, or the system is shut down. The second alarm will also sound when the phone is also removed from its sensor. Here's the actual schematic. For obvious reasons, we don't put the values, but we could give you a brief description. Again, you have your power requirement there on the far left. And moving towards, you have your inputs, that's one, that's two. And then you get into your process section. All right, and then you have your outputs, your buzzers. The primary function of the process section is for switching and amplification. Demonstration.
So I'm going to show you a live demonstration of how we got our machine to work and how exactly it is all put together. So with that being said, I don't know if it has sound or not.
This is during our verification and validation step.
Just gotta take it out. Don't know how.
Testing and making sure it works.
Yeah, no, it's not coming off.
All right. So with that being said on video, you can see that you don't want to hear that. Now, we're more than happy to use it in front of everybody. Would I be able to use someone's phone as a live example? Perfect.
Load the phone. Okay, let's approach the bench, right?
You guys can
Right, yeah, let's approach the bench. I want to hear that buzzer that could create a phobia for phone use.
I'm going to be hearing that all day. Or it's going to be even sounding worse. So, for instance, it remains like that for however long you need it to remain, for an hour, a day. It all depends on how much work you complete or how much productivity you want to spend your time on.
It could be part of a challenge, right? Like,
yeah.
I challenge you to not use the phone.
Yeah.
You give them this challenge container package.
Yeah.
That's great.
In any case, if anybody wanted to grab your phone or just steal it, they're immediately gonna feel like, oh, okay, you're gonna be able to tell that someone's on it. For instance, if I grab my phone, only way to shut this off is for me to actually turn the machine off. Oh, this is Edwin's, right? Thank you.
How about another phone, maybe an Apple phone, an iPhone or something?
You want an Apple phone?
As long as it's not a tablet, it would be perfect, yeah.
So whatever would fit in that box?
Whatever would,
And that-
yes.
And on top of that sensor?
So it could be a prescription that a psychiatrist or psychologist can use, right?
Yeah, it works for any phone. Like I said, as long as it's not a tablet, you should be fine. We can try one more time. For instance, you can close it, but you'll still be able to hear it because there's no phone in there. Okay, the sensor's here. Can't hear anything. As simple as it may be.
Is that a pressure sensor? Is that what?
Yes, sir.
Oh, okay. All right, let's try, here, I have a flip
Yes,
phone.
Professor Maliki has the vintage phone. The vintage phone, would that work for a vintage?
No, it's closed, it's the normal way it is.
Perfectly fine.
That's
great.
That didn't destroy my phone, did it?
That's right.
Find out.
And Engineer Mike, Engineer Juan, the component cost seems to be very low because these are transistor based. So you could actually sell this in bulk.
Yes. We'll get into the costing in a little bit.
All right, great.
Now,
Thank you so much.
does the user want to buy this as a deterrent to using their own phone, or somebody
They
else makes
can,
them use it?
if they like, they can, but it's primarily for somebody else to use to prevent.
Okay.
Yeah.
It's more for an employer or anybody who wants
Or a
to.
student, or maybe even a parent.
As a teacher, can I order a dozen of these and put them in the classroom and insist every student put his phone in there?
Yeah.
While the lecture's going on?
Yeah.
So I don't want you looking at your phone while we're having the lecture.
Love it.
Now, the lab's a different story, because
Engineer Juan.
You can take any disciplinary action into your hands if you see somebody on their phone, like if it was supposed to be in there. During a test, it shouldn't be taken out. During classwork or lecture, it shouldn't be taken out. It's something that you can technically bring into the class. You can notify the student first, just put your phone in there before class starts. It can also be used by a parent to control the cell phone use by their children. Nowadays, kids like to go on their phones 24/7. I have a niece, she goes on that thing every time and cries whenever she's not on it.
And we'll go into design.
Okay.
All right, how does the process happen? We actually take our design process into 4 different phases. Phase 1 is planning, phase 2 is design development, phase 3, which we just completed, is verification and validation. Phase 4 will be design transfer into production. That will be after feedback from this presentation. And within the 4 phases, we incorporate the 8 steps of engineering. For time purposes, I won't go through all of them, but we go through every single one for all 4 phases, throughout the 4 phases. This is just records of our first phase review, and what we did, completed action items and so on, and new action items issued. And obviously we did it for each of the 3 phases we have completed. Now here's the costing. It's a really small print, I apologize for that. But initial costing is $48.95. And that's for all the components, and that's also including costs for a PCB board instead of using the breadboard that we have shown here. So that's total cost as is. Obviously, when we go to production, one of the improvements that we thought about was actually going to surface mount technology. Some of those components are actually less. It's actually cheaper. Another option is the economies of scale. This is the cost for making only 1 unit. Obviously, if you go into multiple units, 10, 20, 30, 100, 1,000, you're going to get price breaks for all the materials. During the design, this is some of the proposed design improvements that we already thought about. Customize the casing, prevent unauthorized access to the card circuitry and the battery compartment. Also modify the casing to allow use of a phone charger, so the phone can be charged while it's in the system. Obviously, I already mentioned this one, use the surface mount components. These last 2 will probably actually increase the cost. To add a wireless monitoring and control feature so that can be remotely controlled, the monitor, or add wireless phone charging technology.
Now, I know some of you guys are thinking, why would you choose us? Just to let you know, MJ is very highly skilled and experienced. As an engineering team, we're very hardworking on our hands with our partners to provide superior products and exceptional value to our customers. We work with our partners to develop any engineering solutions, as for instance, cell phone dependency, so that it's an effective and easy way to manufacture. For instance, it wasn't as hard to make that as you would think it would be. From prototype to production, MJ provides a full service type of support. For instance, if it breaks down, we're completely responsible for it.
Yeah, we'll offer warranty as well.
Yeah.
All right, and then the next slide. In addition, MJ's Technologies is committed to maintaining a quality system that ensures products satisfy or exceed applicable requirements. And that also builds the foundation for continual improvement. And then we have our quality policy objectives there that we must meet. Before we get into questions.
Lastly, we'd like to thank every single one of you for sitting with us and seeing the product that we'd like to show you. We'd like to thank Cartano Industries for allowing us to make
life, have relationships. All right, first question for MJ Technologies, please. Engineer Gola, Professor Gola.
So you envision this primarily being like administrated by like a teacher or a parent or something?
Correct.
It's not really self-administrated?
Correct.
It is applicable, but usually anybody wouldn't just be like, oh, I have a problem. I need to put my phone away. 9 out of 10 times, no one's going to say that. So it's more for employers and managers and someone with like a high need of power to just kind of like regulate it.
So that would kind of guide your marketing plan.
Correct.
That's right. And ultimately, phase 2 could be behavioral also. We could probably distribute it in the field, but for now, under that closed environment of schools. Yeah. All right, more questions. Potential user, investor, Engineer Sean. Engineer Sean.
Have you put any thought into the proximity, something that you have their cell phone in the box, but they still have their watch? And they only need to be the proximity of the phone instead of just a watch.
That's actually something that I thought about. That would be an issue as well. Also another issue that is, as we get into the AR technology, cell phones will eventually become obsolete anyway, because people will be wearing glasses. So that's also something that we have to look into moving forward as we continue with this. So yeah, but that's a good point.
Investor Leone.
Yeah, so what happens if the phone rings? So it's like picturing a educational environment within the classroom, okay, you put a bunch of these in the boxes, and then all of a sudden the phone starts ringing. What happens?
We would just let it ring in any instance.
Essentially, yeah. I mean, you could allow the process could be allowing the student or the employee to access their phone just to turn it down, to turn it off. So all they would do is lift up the case and hit the button on the side of the phone, and that's it. If it's a true emergency, obviously you can't prevent somebody from answering the phone. So that becomes more of a process question for whoever's administrating it.
So there's probably more of a field study in the beginning if that really is
Correct.
an issue. Yeah, and they could probably enhance their inputs. A good question, though. You have more questions practically from an educator perspective, a student perspective, Investor Gonzalo.
Unless somebody wants to go first.
Go ahead. Yeah.
I'm sorry, guys, I came in late. In like 30 seconds, tell me what your business strategy is for your company.
And essentially, our strategy would be to continue taking the improvements and the feedback from everyone here today, applying it to our new design, and then actually testing all those new improvements, and then releasing it to production and start to market it and sell it publicly, release it.
So your business strategy is to get feedback from people and the product?
Currently, right now, this is what the stage we're in. Currently, this is a prototype design. Obviously, when we go to sell our product, it's not going to be in that exact package. It's not going to be a breadboard. It's actually going to be an actual circuit board. So any feedback prior to finalizing our design, we're going to implement it, and then we're going to market it. But the concepts still stay the same.
Is there any intellectual property involved in this product?
The design itself, the actual materials that we chose, the design process that we follow.
Is there intellectual property then you have to protect?
Yes.
Have you patented any of this intellectual property?
No, but anybody that we would require to do business with will have to sign a non-disclosure agreement. So even our suppliers, when we submit the information for them to supply us the parts or manufacture the boards for us, they would also have to sign the NDA prior to us giving them design information.
Well, the NDA doesn't protect your intellectual property, right? NDA just
opens up more information.
Right?
It's for more.
So are you planning on filing a patent?
We could do patent studies. Honestly, we have not really thought about that just yet, but we should do a patent study and see if it's actually out there already. Maybe there is a patent out there already for something similar.
I would say it's hard to get investment money if you don't have anything that's protected in some fashion. Right? Everyone's got a good idea, but if you haven't protected your idea in some way, I could go over there and take a picture with my cell phone and or your circuit diagram. We've got a whole bunch of smart people in this room. If you don't have your idea protected in some fashion.
Well, that's why we didn't disclose any of the actual values or the components that we use. So yeah, you could take a picture of the diagram, and if you have some electrical knowledge, you could understand the general concept of the design, but the actual way to make it actually function, you won't have that information.
And ultimately,
and even if you take a picture, you won't be able to tell from the breadboard itself.
Right. Last question. Are there any privacy issues that you have to deal with this product?
Privacy issues? No.
Yeah, they have a very unique solution, right? Because from a psychological perspective, could actually be part of a bundled solution if it becomes a mandate by the Department of Education to be part of every single school, some type of management of cell phone addiction. So I think ultimately for them, it's not just so much selling, but it could be partnering with institutions. All right, one final question so that we can close up before the EOF Awards dinner tonight. One final question for MJ Technologies, particularly from a student perspective. How would you feel if there was a mandate in school for you to give up your cell phone for that moment in time? Any students in the house here? Seth, from a student perspective. All right, go ahead.
Well, kind of from a student and an educator perspective, part of what my brother does is he manages special education studies, and for them, a lot of them have learning disabilities, so a lot of what he's teaching them is how to use their cell phone to help with their education. Like they have learning disabilities, so they struggle with basic maths and stuff. So it's like, oh, would you look at that? This has all the basic maths you need, so you don't need to worry about that. You can focus instead on your reading comprehension. I guess that would be more of a policy issue.
Right. So that would be a separate policy probably. So go ahead, Engineer Mike.
Yeah, that would be more of a policy issue, and also when in the industry too, cell phones are used commonly, even in the workplace. So you're not going to prevent access from every single employee at every single company. And the same goes with the classes too. If the teacher elects to use the cell phone as a learning tool, then for that day or maybe for that whole class, they decide not to use the system.
It all comes down to the issue.
All right. So once again, many thanks to MJ Technologies for taking the path less taken, which is developing an anti-cell phone use solution. All right, thanks so much. Again, an applause. And last but not least, the Mars Company with their beverage solution. Engineer Roman.
Okay, I'm just going to start this now.
All right.
This is already plugged in.
All right, thank you again, everybody, for sustaining your interest. Hopefully, this is not, but not the least. Hopefully, we end on a high in this class group. Thank you again for your feedback so far. All right, Mars.
Just sound. Okay. Hi, everyone. You know, they always save the best for last, so I know this looks a little weird, like, you know, engineers, we're all male here. Not really, but of course, it's actually our logo. And we're located pretty much in the heart of New York, in Manhattan. And introducing pretty much my team. This is Mike Shimo, our systems engineer. I'm Amethyst, I'm the project manager. And that's Rowan, and he's our product marketing engineer. What we stand for is that we hope that you come to a journey with us, and we stand to, we're environmentally friendly, and we're aware that we all need water, but there's always a solution to keep everything at low cost and to make sure that everyone gets what, that we create a clean and sustainable infrastructure. And for our next couple of minutes, we're going to talk about why you should choose Team Mars for your water issues. And this is, sorry, this is Roman.
Hey guys, what's up? I'm Roman. So can everyone raise their hands if they drank water today? We got a lot of people, right? So yeah, water is the most important resource. We believe it's worth fighting for. Everyone needs it to survive. Everyone had it today. Unfortunately, almost 25% of people drink contaminated water. There is a water crisis. 1.8 billion people are affected by it. So on the Maslow's hierarchy of needs, water is a physiological need. So what that means is that it's basic need. You can't really go after any of the other needs like safety or belonging or esteem or even self-actualization without water. You need to have all your physiological needs met first before you can pursue the other needs. So millions of people drink contaminated water. So that would be like in a family of 4. One of those people is drinking contaminated water. And one of those people could potentially die from drinking that contaminated water. So there's a lot of common water contaminants. Lead is pretty common. We saw it in Flint, Michigan, and Newark, New Jersey even. The lead service lines in Newark were contaminated, and people weren't aware of that. It was actually before water entered the house through the water mains where it got contaminated by the lead service lines. 75% of Americans are chronically dehydrated. We believe that with our product, we could help decrease this number and make sure more people are consuming water. Clean water is a necessity. So yeah, in Flint, Michigan, it's still a problem. It's been a problem since 2014. People are still drinking contaminated water. Jaden Smith actually started a portable water filtration unit called the Water Box, which filters out water. We're hoping to hopefully come to a partnership with him to make smaller versions, which is what we designed, to bring into people's houses. That way everyone can have a clean water source at their house. Because the Water Box is a good idea, but you have to bring your own water containers and you have to travel away from your house to pick up water. And if it's in your own home, it will be a lot simpler and a lot more accessible. So this is our prototype of our solution. We designed a smart pitcher. There's a 3-stage filtration system. We have a pH sensor, temperature sensor, and a LCD screen, which will read out your temperature, everything that you need. That will let you know if the water's contaminated or not. It'll give you your filter lifespan, and we're also working on an app right now to help let you know when your filter needs to be replaced, what the status is of your water. All of this is done in real time. I'm going to pass this off to Mike to explain this a bit more. Amethyst is going to explain it.
Okay, so these are the key aspects of our prototype. It removes more TDS. TDS stands for total dissolved solids. They're just mineral salts and cations and whatever it is that could be in your water when it's not filtrated. There's 6 stages of to filtrate your water. It's built to last, especially because it's also portable, and it reduces the usage of too much water bottles, and obviously that makes it eco-friendly. And to move forward, we have Mike Shimo, our systems engineer, to talk about more of what our circuit is all about. This is just a little something that we wanted to share with you guys. I'm sure we're all adults here, and we just wanted to say that, you know, like, you could drink all the coffee and alcohol you want, but water is pretty much the most important thing.
So here we have the pH scale. The middle of the pH scale is basically your neutral water. The left of the pH scale is more acidic, and the right of the pH scale is the more alkaline your water is. pH basically means potential of a hydrogen. The more left you go, the higher the hydrogen atoms go. The more right you go, the lower your hydrogen atoms go. So these are the top name brands of the water industry, the water bottle industry. Right now you see Aquafina, Dasani, Poland Spring. They're more on the left-hand side of the spectrum, which makes it a little bit more acidic. And now on the right-hand side, you have Essentia, all those big name brands, the expensive water brands, 9.5, Evian 7.9, Smart Water 7.6, that's towards the middle. And there's actually only one water bottle in the industry that actually has a 10 pH level. It doesn't go any more higher than that. And the highest you could go on the pH scale is 14. So here we have our function block diagram, our PIPO, power, input, process, output. It's basically all our components that we have in Neptune, our product. These are some of the components that I'm going to go over in our slide. So here we have our pH sensor that's going to be in our unit. Basically, it's a probe that would touch the water, and it's going to read the current state of your pH levels. These are the dimensions of our pH sensor, nothing too big. And here's our schematic. It's an analog schematic, so it just goes straight from the pH to our Arduino and onto our LCD screen. This is our temperature sensor. Almost does what the pH level does. It takes the real-time temperature of your current liquid state. This is another schematic for our temperature sensor. This is our liquid crystal display. It's 16 by 2, which means you can fit 16 characters on one row, but it has 2 rows as well. This is how we built our LCD schematic. This is the brains of our whole product. We used an Arduino. Basically get all of our programs and make all of our components work. And this is the Arduino schematic, all the parts that are inside of our microprocessor. This is the JK flip-flop, also known as the Jack Kilby flip-flop. What that does is it actually turns on and off our circuit. This is the pinout of the JK flip-flop. This is the switch with our JK flip-flop. Every time you press it, it's going to turn on, or if you press it again, it's going to turn off. This is our LED. We only went with one LED, but it has 3 different colors: red, green, blue. Red, it shows all the pH values from 6.5 and lower. Green is going to show the state from over 6.5 and 7.5, and anything over 7.5 will show green. I mean blue. Sorry. Temperature on Neptune is basically going to show the contrast of our characters.
The resistors, they basically limit the current into our LED so it doesn't burn it out. And the buttons is just a little fun way to have our product more interactive. And here's Amethyst with the business side of our product.
Okay, so this is just the total unit price. This is without anything else but us working on it and prototyping. So if we really wanted to sell it retail price, it would be around $100 to like $120. But the materials isn't really the problem, but keep in mind we have to worry about the tooling proprietaries, the PCB molds and the parts. So bulk really means nothing, but until we are actually able to patent it and we have credit history with our manufacturers, we could always fill out all the contracts and we could always fill out the contracts with them and work out something with them that we could improve our prototype with. So obviously I mentioned patenting it. So even before we actually go off manufacturing this, we have to make sure that this happens so that they don't just, you know, as he mentioned before with other people, that they could just take this idea and take it for themselves and put their logos on it. And another idea we could go for is developing it locally. It helps. Sorry.
Go ahead.
It builds more business locally, and it also we also have control for pretty much everything if we do it locally instead of giving it off to China and building it for us. So now we present to you our prototype. And this is the future of clean water. So we hope that you know to drink clean, drink smart, and drink with Mars.
So to end it all off, it's 2019. Do you know what's in your water?
So we're going to go off into our demonstration right now. So if everyone wants to just come up here.
It is pretty impressive, guys. And I've owned.
Resets the actual reading of your temperature or your pH level. Oh.
So right now the LED is showing red because it's under 6.5 pH. So right now pH level should be around 7.
So that's acidic water, right? Acidic.
No, this is more neutral.
More neutral.
Yeah. Yep, right now it's green. The pH sensor isn't perfect. You know, it has its plus and minuses. So right now it's around 6.96. So it's almost at 4/thousandth of a way from the 7 pH.
So this actually is the potentiometer. It just helps brighten or dim out the actual LCD.
Characters, yeah.
There's still potential for improvement.
That's it, yep.
Good, fantastic. All right, thank you, Morris. Thank you, Sly.
So we would just like to personally thank Professor Cartano for bringing all us together and for this presentation. And we're really happy how it came out today. I know we came in last, but it was still a journey and it was really fun. And we made friends along the way, and that was really important. So I would really like to thank my boss too, Tom. He's in the back. And he was helping us with our project too. So.
Thank you, Tom.
Okay, great. That's it.
All right, Q&A.
I hope. If anyone has any questions, please let us know to improve possibly our ideas.
Thank you so much. Apologies for the technical difficulties here. I tried to adjust everything in the podium as I can, but the noisy speaker is still fairly noisy. So, all right. Questions for Mars? All right. Professor Ugola, Engineer Ugola.
Yes, sir.
Just I guess a chemistry question. Is pH level, is that the only thing I would need to worry about in contaminated water? Like you listed all of those possible contaminants.
Yeah.
Is pH going to be an indicator, like the only thing I need to concern myself with, or could I still be drinking lead and have a neutral pH water?
Well, that's a possibility that you could be drinking lead, but our filtration system will filter that out and let you know when it needs to be replaced and stuff. So we get most of the contaminants out. We're still in like the development stages and stuff, so we're hoping to improve and get a actual sensor that'll actually detect the actual contaminants like lead and other stuff like that.
Is this picture going to filter the water out, filter the contaminants out, or is it just going to tell you that?
It filters out.
It filters out.
There's a filter in there.
There's a filter in there. It actually has a filter. If you wanted to use another type of filter, like a Brita filter or something, it would be able to fit in there.
Okay.
It's a universal filter.
Engineer Kyle, Investor Kyle.
So you might have gone over this, but I didn't catch it. What are the benefits of drinking a neutral pH water versus acidic or alkaline?
It's a good question.
It's better for your body to like balance everything out. You don't want to be too acidic or too basic. There are certain times where you do want to drink something that's more acidic, but for the most part, you want to remain neutral.
For drinking water. The more electrolytes that's in your water, the more acidic it's going to be, like a Propel or anything like that.
Yeah. Plus, it causes bloating and stuff like that. You don't really want that when you're drinking water because you're trying to purify your system. So if you want to drink soda, you can drink soda.
Yeah, but our filter is mostly for water. Nothing else like that.
And Marsh, I also heard that there's some people who are really pH sensitive when it comes to water.
Oh, yep.
Yeah, especially when it comes to infants. Yeah. More questions? Engineer Bill Boardman?
So with your filter, the pH, is it adjusting the pH, or is it just telling you where it is?
It's just telling you what it is.
Would you look at the feature of maybe, whatever it is, 7% based on diet,
What we're actually looking into is more of a probe, a testing probe. It's not like something that we could readjust and like certain things that we want really is for just testing purposes. It's not something that we want to. Yeah.
Is there a life on that pH meter, do you know? Is it, I mean, the Brita filter is supposed to change every 3 months or whatever.
Yes.
How long does that last?
That pH sensor, it lasts for a long time. It's not, it's sustainable. You don't have to like just dispose the actual probes, and also the temperature sensor is also.
It's moisture proof. You know, you don't have to worry about it rusting on you or anything like that. It's stainless steel.
Yeah, I have a question. Yeah, I have a question as well.
Yes, further.
Because Brita has a value proposition based on its brand.
Mm-hmm.
It doesn't have to talk about its value proposition anymore. It's based on its brand. Can you talk a little bit about that quote-unquote psychological demand for clean water, and how would you tap on that? So, play on words. Tap on that.
Psychological.
Can we say that one more time?
Yeah, so if you think about it, right? People buy Brita filtration water systems because people are buying them. So the value proposition is really because you want to have a Brita system and you have tap water. So the question for you is, what is that psychological, quote-unquote, marketing you're going to do with your clean water system? I think Roman mentioned it a while ago. You mentioned electrolytes. What would be that spiel to get people to buy? And if it's less than $30, $40, people will spend it like this, right? So what would that spiel be? We have Professor Kovachuk in business here, and she can actually tell you whether that would work.
I think for us, we're mostly proprietary of clean water. It's itself like where you can take our technology, but we really just want everyone to be aware of what they drink and that it's safe, and it's also we could streamline it. You could take this technology and possibly put it in your actual faucet. You don't have to just buy the actual pitcher itself. We could actually create a business in terms of like multi-platforming it, I would say. I have no idea if that answers your question or not.
It's a lifestyle pitch.
Yes.
It's a lifestyle pitch. Business expert, Professor Kovachuk.
We know Brita doesn't make them buy it.
Yep.
They don't tell us much about why we're buying it, what we're getting them to buy it, what it does for us. So that seems to be your difference, is you're educating us as to the well-being. So I think it's critical.
Tom, Investor Tom.
Manufacturer, I just wanted to say that I appreciate the plans to keep the production here domestically instead of sending it overseas.
That's actually true. That's true.
I mean,
made in America, WeatherTech.
Yeah.
Neptune, made in America.
I mean, business-wise, of course, like the material is probably gonna mark up the retail price, but it doesn't matter in terms of helping the economy build itself from within, instead of putting it out there. We can always get the materials from out there, but assembling it here and having our control on it would be the more ideal portion of this business.
All right. One final question so that we can wrap up. We have to wrap up pretty quickly because there's another event here. One final question, especially from the guests, previous EET Capstone alumni, partners, faculty. All right, a big round of applause for Mars Company. If I can ask all of the Sharketeers to come up, we'll have a final video with Dan, and many thanks to the IEEE team for receiving everybody, and many thanks to the audience for participating in the future funding and redesign of all of these product pitches. Thank you so much, and bravo to all of you guys for having the courage to sit up here. It's 10, 12 weeks worth of work, and I thank you so much for having the courage to sit in front of everybody here. All right, come on up, guys. Just to celebrate the faculty who helped you come up to the stage. Professor Rodriguez, Professor Aska, ELT 231. All right, engineering faculty. All right. All right, our final minute, and we need to wrap up and close out. All right, thank you so much. Everybody say engineering for life. Engineering for life. Thank you so much, Dan. Thank you so much. All right, guys, let's wrap up. Let's lay down.